Oof.
Yes, my brain has been totally warped.
Yes, I bet.
Can you recommend any specific games? Because I've got some Anglo games. I went to Lakeshore and I bought everything that I could think of. And then I actually have the hand manipulatives that I've used with the elementary level.
Yeah.
And I have a 3D carpet, huge 3D carpet with the shapes.
Yeah.
Can you think of anything else that I should start getting?
Game-wise? So what grade are you going to?
9 to 12.
9 through 12?
Uh-huh.
Ooh. So I was going to say, I wasn't really much of a game user. Like the one that I use, I still carry like the 24 game. But little card game things like that are nice. But I don't know. She might be. Let's make sure that you guys know each other before we get past this thing. So what I'd like for you to do is that as you're finishing up, I'd like for you to talk with your table about specifically some of these things that you maybe have questions about. Okay? How you doing? You having some ideas? You guys have any questions about any of these up here?
We tried.
Huh?
I said we tried.
You tried? All right. So, is it all clear, or do you have any questions? Or okay.
I'm curious to hear what you say.
Okay. How do you mean?
What you believe.
Oh. I'm not showing you answers here. Okay. Was did the lesson seem realistic to you all?
Oh, yeah.
Okay, good. We're trying to figure out. What I'm trying to find out is like to what extent case studies could really help us kind of prepare ourselves for a lesson that we're about to do. So this felt good. Okay. Did you see anything new in the way the students approached it than that you hadn't anticipated?
That one, the error.
Yeah.
I wouldn't have seen that error.
Yeah. Have you seen it before, or have you noticed it before?
I've never seen. Which is, sometimes, like you said, when students don't write things down.
Yeah.
When their thinking's not out there, you don't know how they got that wrong.
Yeah. Right. So that's interesting. So now that you're aware of this type of error, maybe you might be able to spot those.
Yeah, because I'm like, oh yeah, that makes sense. A kid would think that.
Yeah. Yeah. Well, good. All right. Okay, so let me get everybody's attention at this point. So we've got a little time to make our way through this, and I want to draw our attention to a few of them that I care a whole lot about, so I'll kind of run us through a couple as well. The 8 effective teaching practices are something that are worth investigating more, and let me just start off that way. I'm going to give you guys just a taste. But NCTM wrote a book in 2014 called Principles to Actions, and it is where they introduce all of these effective teaching practices. I personally think, and I'm going to give you another book recommendation here in a moment, but I think it's a must-read book. And honestly, most people who have read it would agree. It is just absolutely something that if you want to be a great math teacher, it would be silly for you not to have this under your belt. It's really going to give you some cool insights. Principles to actions. And principles like, not like school principles. Like, yeah? Like, I don't know. What's a synonym for principles? Beliefs, or I don't know. Core beliefs. Okay, so this is a real case study. This is his name's not Mr. Donnelly. All names and locations have been changed to protect the innocent. But we can explore all of these effective teaching practices. There's in some ways they show up, and I want to explore them a little bit. So I think the first two are a little bit tricky, so I want to explore that kind of first. The mathematical goals one is, I point that one out because really it's pretty straightforward. You see very quickly that he is engaging with it from the first sentence. It opens it up. And all the way through line 5, you really know that Mr. Donnelly knows what he's trying to accomplish. And in fact, the way that we talk about establishing math goals, it's about making sure that the teacher knows what the goals are so that they know what the students are learning and understanding. And importantly, this is my favorite part, that they frame the decisions that the teacher makes. So there are a lot of decisions here. He selected a task. That's a decision. How do you know if that task is good enough to get the kids to the goal if you don't really deeply understand the goal? You can tell throughout, we'll explore all these in a moment, but you can tell throughout that Mr. Donnelly is connecting students back readily to the goals, not losing sight of unit rate, scale factor, and scaling up. Right? So we know that he had it. Now I'm going to say I'm a public critic of posting teacher goals on the walls. There are ways to do it that can be really, really productive. And there are ways to do it that can be really counterproductive. For example, would you guys repeat after me? To get to the other side. Okay, I got a good joke for you. Why did the chicken cross the road? I mean, it was already a bad joke, but it's even worse if you know the punchline. Right? And I think there's a version of posting learning goals that's just like that. Like, hopefully we're not comedians and we're not just telling jokes all day. We're teachers, and we're trying to get students to create learning. And just like a comedian wants the audience to appreciate the joke and have a moment where they are, having a ha-ha moment, the teacher wants what? An aha moment. See, I've been working on this one. And within all of that, we have to remember, we can present goals and the whole world of identifying vocabulary first and having all the student goals listed. All right, what are we going to do today? Today we're going to learn that an acute angle is less than 90 degrees, and a straight, they speak more formally when they are mimicking that than they're meant to. And from that point on, they are no longer creating mathematics; they are only mimicking it. So we can create learning goals that are appropriate for kids. In this one, if I had to put something on the wall, which I did as a teacher, I would put, I will reason about the size of a candy jar. Not a bad one, right? Pretty straightforward. It's connected to exactly what the task is. And in fact, later on, I could say, what kinds of reasoning did you use? And we could talk about I can statements later, once they've done them. So that's important to throw out there. I think everybody who's ever said learning goals matter have really intended for it, this whole thing, clearly state what the students are to learn. It's not saying say it to the student. It's saying be aware of it as the teacher. Because how else can you make decisions if you're not critically and intricately connected to that? The thing that's also maybe harder to explore in this task, in this case study, is the selection of the task. But this task clearly gets us somewhere that we want to be. The students access it in multiple pathways, right? And this is the defining point of a good task. There are actually a lot. Let me take that statement back. There are a lot of things that we know about good tasks. But one thing that's essential is that it has multiple entry points. That it takes students where they are and it moves them forward. You know about the zone of proximal development? I've sometimes wondered if every problem I was giving to my kids was outside of their zone of proximal development because they just give up immediately. That kind of issue. We have to identify problems that are just going to meet those kids where they are and move them forward. And that takes some work. That's the hardest part, I think, about being a teacher, is knowing when to use certain curriculum so that it works for kids. So we see this throughout. The kids are clearly accessing it. And Mr. Donnelly does a nice job of connecting them back to prior understanding, which is so important, is that they have to connect to current understanding. So did you see that early on? So let's explore I got a couple more that I'd like for you guys to explore. So at your table, I'd like for you to talk about representations. Where did Mr. Donnelly use and connect multiple representations of the mathematics? Come up with some kind of example where that's happening and see if you agree about what that means. This is, by the way, number 3.
He chose the groups because he chose them for different representations, so they may represent those in different ways.
Oh, okay. That's interesting. What did you say, Angie?
Well, that was intended for them to come up with some different project lists, and this was not.
I think the selection is really powerful, right? It could have just, maybe that'll connect to a lot of the other things we're talking about, but he knew that he needed them to have different versions of, especially in this case, visual and physical, models.
When he chose those three groups to share, he knew that was his target. I mean, that was his targeted area.
How do you know that?
Because he decided that he would ask us group 4, 5, and 2 to share their work.
He went back to what he was looking at.
Yeah,
This is what
instead
his
of-
goal. He went back to his
He
goal.
just walked around and he saw all of this and he picked those three groups.
Got it. Got it.
But I like the fact too that he chose one that was an incorrect thinking, so that he could change, so that he could show how this was not correct, but this was, and so that they're thinking, so they went to imply, probably went into why
So
it was not.
did you see where they did group 1?
Yeah.
So that was the very end of it, though.
Yeah.
Right.
So that, I mean, in the
lead with
sequence,
what's-
yeah.
Right.
I loved how he handled the group 1's thing at the, I don't remember where that is. Towards the end of it?
Well, I just looked at this part right here. So.
Yeah, so check out line 74 is where they talk about group 1.
Right.
And I really, to your point, I really like how he handled that.
Yeah. A little different class sizes.
Just a little. Did you guys have an idea about the representations? Did we see some examples of it?
18 to 22, and then it's the same.
Yeah, just keeps on coming back to the different representations. I think I'm hearing from a lot of the groups really similar things, but I think it's worth pointing out. Inju and Melissa, would you guys make a point of where you were seeing the representations so we can explore that together?
In the part where, like in the section where he chose the groups, where he chose.
What line is that?
It's in the third paragraph. It's like 18 to 22. And then where he chose the group that he was going to help his
I think I was hearing that everywhere, right? It's interesting because I think it's really powerful. That line, right, that actual little paragraph right there is one of my favorite paragraphs of the entire story. Because it's obvious. I mean, right? It's obvious what he's doing. He's aware of who he's calling on so that he draws his attention back to the goal. But let me just skip ahead for a second and we'll come back to this. You can't facilitate discourse in a math classroom unless you know what's happened. Unless you know that you have multiple representations so that you can build consensus and shared understanding. And what is facilitating discourse? You guys have heard about the sage on the stage versus the guide on the side idea. Well, there's another version, and that's a person who's an orchestrator, like a maestro. That you would orchestrate the discourse and facilitate it. And in line 20, whenever he says, he looked at, there are at least 8 groups. He looked at least 8 groups, and he chose 3 of them, and in that order for these reasons, to present to the class. Why? Because either their tasks were shared, they were connected to the goals, and they were accessible. Right? The sophistication thing that he mentions. It starts off at a low sophistication level that it's accessible. Scaling up is pretty accessible. Was that the first one he did? What order did it say? 4, 5, and 2. Do we have those that work in the back? Yeah. Okay, so 4 is scaling up. 5 is scale factor, which is also pretty straightforward. And then we get to unit rate, which has got some abstract thinking to it, right? Hard to understand what that is. Look at that sophistication that he picks out. And that doesn't happen on accident. That happens because he was very, very thoughtful about it. And I'll tell you what, you don't know what kids are going to do unless you do the problem. There's some of my favorite math researchers say that you can basically find out the quality of a teacher by how they can understand how students work. It actually should be the thing that we work for the most. If we want our practice to be best, we would know all of the ways that students would solve our problems. And then boom. Then we're ready for it, and we know how to orchestrate the discourse. By the way, I've been saying orchestrate the discourse. That's the second book I was going to tell you about. If you read this case study and you thought, man, it would be all right if my classroom looked and felt like that, then you got to read the 5 practices for orchestrating productive math discussions. 5 practices for orchestrating productive math discussions. I'll say it one more time, but just a couple of those words in a Google search will help you find it. 5 practices for orchestrating productive math discussions. It's by Smith and Stein. And the reason why I tell you about that book is because it is a roadmap to changing your practice. It is remarkable. In my opinion, a must read. So did you guys see this? I want to point out this idea of building on and honoring student thinking and giving opportunities to share ideas and clarify understandings and advanced thinking. So I pointed out 20. Is there some other place that you guys saw facilitating discourse that's important to point out? This is number 4. Nice and loud. 27, what should we be looking at? Did everybody hear what Donna was saying? You guys, I like this because what she just said, she said it in different words, but let's point it here. Donna said defend and discuss, but develop convincing arguments. That if we don't create that opportunity, it won't happen. Another example, anything else that y'all want to point out? That especially connects to building on and honoring student thinkings or any of this? Donna, you got another one? Line 30.
Where he says he makes the connection that all the students can see the skill factor identified by group 5 was exactly the same number of entries from the table as group 4. So he took out the 2 were connected.
So I think you're on it. You're like hitting some things that are really interesting here. So I haven't actually heard anybody talk about that one as this one. But look, like for a moment, take what Donna just said, that line, and think about what it does to advance mathematical learning of the whole class. I'm gonna bounce around and follow your line of thought here because I like where you've taken us a little bit. I'm going to come back to the questions and that one. Supporting productive struggle and learning in mathematics. Number 7. I think that there's a space that you guys are all, that you'll know what I'm talking about whenever you think about this. And I want you to really know that I'm not hating on you. I'm hating on the system. Have you ever got most of your class solving a problem in a way that is the right way, and then somebody else gives another way to solve the problem? And have you ever shut that other way down? No. Sorry, what?
There's more than one way.
So you know what is remarkable, and maybe you guys have something figured out. But I'll tell you what I hear is so often when we get one way of solving a problem, and somebody else detracts from that, or some students start losing, and they just start floundering because they can only handle the one way. Have you guys seen that though for a kid?
I see. Sorry,
You're good. Talk it. Go for it.
When some of our elementary teachers, they struggle with, because they're used to that textbook and this is how it's showed to do it, and then a kid will come up with it, and I'll have the parents call me and
Yeah.
say, well, hey, can you tutor my kid that's in 4th and 5th grade because we don't understand this method, but we can show them how to do it at home. But
Yeah.
we can do this, but the teacher says it's this way or this is the only way to do it.
Yeah.
And so then when they come into middle school, and the first thing I tell them, probably the craziest teacher you'll have, and there's more than one way to do math. And if there's more than one way, if there's only one way, I'm going to say, nope, this is the only way. But either way, there's more than one way. And they're all like, they can't believe that they...
Yeah. So, what's that? Is there anything that you can do only one way?
Really?
So the trick, yes. So the trick is a lot of procedures. You have to follow the procedures exactly that way or they don't work. Right? So there's a version of mathematics that is procedure-based. Textbooks tell us this too often. That makes us believe that. So I think that's a big point here. Mr. Donnelly values that there are other opinions, and this idea that we can have not just other opinions, but there are other things that really build out the full understanding of the mathematics. It isn't about performing. How would I teach a kid to perform on solving proportions if all I cared about is that they could find the missing value? I think you guys know. Cross multiply and divide works. Time and again it works. Because it's a rule, a trick. But if you want the kids to understand what's happening there, we've got to connect the dots and allow for them to see that connection. Okay, I love this one. All right, but I want to go back now to pose purposeful questions because I think this is one that's worth spending a moment on. Oh, wait, are we almost out of time? We're done at 50 or 55? Good. Okay, I want to hit this one then. Do you guys see the questions he's asking? Do you see how consistently he is asking the students to explain, to explore their reasoning, to make their reasoning, their thinking visible? It's a pretty beautiful thing. And I want to draw your attention to my favorite line, and it might not blow you out of the water, but if you'll turn to the top of the second page, line 50. Line 50 is what I love. All right, so let me see. I think I'm going to move to the front. Line 50 is where, again, he's putting a situation in front of the students where they have to justify, where they have to see the mathematics for what it is. So I want to make a challenge to you guys because we got to wrap up, but I want to hit this one right fast. Did it lose me? In mathematics, overall, when we go back to the maps circles, right? I said conceptual understanding matters, right? When we do this week with you guys, that's what we're gonna focus on. And the reason why is because I think it's so often hidden from us. Let me see if I can make a quick case here. Please don't be permanent. The teacher way to solve the problem. As explained to me by a student, the first step is to cross out the equal sign. And after that, we have no clue. Okay? Because kids don't know the rules, right? Okay, so why do we cross it out? It's because we all know. What we're saying is that tells us what things to multiply. There are 3 strategies that we use to solve proportional problems. What are they? Multipliers, which here they call?
Equal to the ratio.
Yeah, so we have, let's go to what Mr. Donnelly is using. But I'm tracking with you. So we have scale factor, which is a multiplier. We have a unit rate, which also is a multiplier, just a different kind, comparison to the other, the ratio. And what else? What else do they use here? Yeah, the table, the scaling up. 3 ways that, yes, we know cross multiply and divide, but for right now, let me just convince you that's a trick, and so hold on. So here I've done it. I've shown you the trick, cross multiply and divide. It works, doesn't it? Why? Does it use scaling up, scale factor, or unit rate? What would we expect to see if it did scaling up? What do we see on our documents when we look at scaling up?
You multiplied by one factor everything in the problem. You multiplied by 5 everything in the problem.
I did?
Well, not everything, but yeah.
So, did I multiply everything by 20 or 5? I didn't. If it was scaling up, I'd expect a table. If it was scale factor, what would I expect to see? What is the scale? What is the scale factor? The scale factor here was 20, right? Did you see it? And the unit rate was 2.6. None of them are here, are they?
No.
What does 1,300 mean in the context of the candy jar problem? Anybody got a guess? 13 times or 1,300 times? How many candy jars would we need to have 100 Jolly Ranchers? To have 100 isn't it 100 Jolly Ranchers? How many candy jars would we have to have 100 Jolly Ranchers? 20. Right? That's what the scale factor is telling us, is that it's 20 of those jars. So let me do the hidden math for a second. Now what is it? I have my unit right. If for a second I ignored, let's just go back a step. Now what is it? Turns out cross multiplying and dividing hides the mathematics. That in fact this is not math. Cross multiplying and dividing is not math in itself. It's arithmetic and it happens to work. It's a trick that works because it's a rule that somebody came up with, sure. The challenge for all of this is to say, what is the mathematics? What is the mathematics? Conceptually, what is it? And for students to come up with an understanding about proportional reasoning, this problem, you know, could be completely different. A teacher could teach a student how to do cross multiplying and dividing first, as a rule, and then give them the candy jar task, and what would they do? They would do it, and would they get 260? Yes, they could perform it. Would they have learned anything about proportional reasoning? My argument is not a lick about proportional reasoning. And in fact, this just happens to be one example. So go with me. In the first 9 weeks, I want a week. We're going to try to figure it out together. Slowly and patiently, we're going to try to look at what's happening in our grade levels so that we are making sure that our students and us are exploring the concept deeply. That our students are positioned as authors of the mathematics, not memorizers of tricks that happen to work. That's our goal. Are you good for it? You'll give us a week? Guys, I appreciate all that you guys have done today. I would love if on your way out, you would take this survey. It's on your phone or on your iPad if you have one, or you can complete 2 of the sentences on your index cards. But all I need is 2 of them.
Can I ask you a quick question?
Yeah, and I'll stay around for questions. There's nobody after me.
Is the afternoon going to be like this?
Same session. Afternoon is the same session.
All right, so it's going to go.
Yeah, thanks.
Also, so the 10th grade, I thought our counselor meant, do they take it regardless of after they finish geometry, or are they only going to take it in the 10th grade? She came
Oh, I
back
see.
saying they were going to take it when you
They're getting better.
No.
No.
No matter what class you're in, if you're a 10th grader, you're taking it.
So if we have 8th graders take Algebra 1,
But they punctured it with
very small school, we just implemented that last year, we just got there.
Should you,
Try and throw in some of those 8th
they
grade
released
concepts
from home health last week?
before the test, or just see what they have.
I wouldn't. I mean, I wouldn't make so like. I think naturally. So that's why I made the algebra progression. So do you have that? The algebra progression shows the pre-algebra concepts that are directly connected to algebra 1, so that you can build off of them. So anytime you're introducing an algebra 1 concept, you don't have to do it like it's brand new. You can go back and say, well, here's what they learned in pre-algebra, right? And you can do the same thing looking at middle school. Altogether, 5th, 6th, and 7th grade are connected to pre-algebra now. So I wouldn't spend any time going back and teaching 8th grade math in algebra as a matter of test prep. I would do it as a matter of foundational, like launching points in my lessons. And by the way, middle school geometry is the most amazing resource for context for algebra 1.
Just when those kids, 6th and 7th, all
Yes. Yeah. I'll take them. Thank you so much. Thank you. Are you going to give me your card? Oh, you're doing it up here?
Or there?
Cool.
I mean-
Whichever one you do.
Oh, okay.
That's good.
I'm like,
All right.
I don't know, I was trying to figure it out.
No, anywhere you want.
So like for the 10th grade test, our 10th graders, when they get to 10th grade, they get to choose if they want to take Algebra 2 or they want to take geometry.
Oh, really?
Yeah,
Wow.
and only because being a small school, we have VOTEC. So
Yeah,
there
yeah.
are kids who
Thanks, Angie.
go one way because of that.
Yep.
Because VOTEC only gets back in time for 4th hour, so we switch those 2 classes every year. You know, one year it's 1st hour is one, and next year 4th hour is the other.
Yep.
So is that something that we need to look at a change?
It's a pretty unique case.
Mhm.
So
I don't know.
I
Do
would.
y'all have the same thing? All your sophomores take geometry right now?
Yes.
They do?
So I don't think I'm going to change anything like you suggest. No, I will start with like Algebra 1 students, kind of.
What
yeah.
I would.
Then I will inject that with my 10th graders because I teach geometry. I will just have to make a change. I'm not going to make the school district to change the schedule.
Yeah.
No.
Yeah.
Yeah. We just kind of put up with it this year,
I
and
think-
it will all work out.
I think if I were you, and especially in a small school,
Yeah.
I would do a quick research study, gather some data. How do students do if they take it in the Geometry Algebra 2 sequence versus the other sequence? Because you could probably find some quick data. School districts have ACT scores
Right.
for all their students.
That's why we changed.
Um,
All your
ACT score.
sophomores?
Yeah.
Thank you.
ACT score has improved after the switch because I've been wanting to do that for many years, and I found it years ago. And they students.
Thanks. All right, Ellen. Ellen, right? Yes.
Melissa that led the pre-AP math, she was wonderful.
Who did? What?
Melissa from the pre-AP math. But I was curious.
What are you? Oh, wait. I don't know.
Yeah, the pre-AP math.